Hello guys, you are welcome. In this video, we will cover the theory of quadratic roots. And please, before we get into it, if you are yet to subscribe to this channel, please do so and turn on notifications so you get updated on each new video. Thank you. Now let's begin. A quadratic equation is a polynomial of the second degree with the general form ax squared plus bx plus c equal to 0, where a, b, and c are constants. Every quadratic equation when solved will give two x values. These values are called roots of the equation. There are about 4 methods of solving a quadratic equation. There's the factorization method, that is for reducible quadratic equations. Then secondly, there's the completing the square method. Third, there is formula method. And finally, there's the graphical method. Whatever method you employ in solving your quadratic equations, you will always have two roots. And it is usual to call the roots alpha and beta. Now, if the standard quadratic equation ax squared plus bx plus c has roots alpha and beta, that is x is equal to alpha and x is equal to beta. From this, we can deduce that x minus beta equals 0 and x minus alpha equals to 0 and x minus beta is equal to 0. Now, in finding the product of these two, we will now have the quadratic equation back. That's x minus alpha, x minus beta equals 0. Now, in expanding this, what we will have is x squared minus alpha plus beta x plus alpha beta equal to 0. Now, let's bring this back down here. We have ax squared plus bx plus c equal 0. Now, we want to make this in a form that is directly equivalent to this. So what we'll do is that we divide through by the coefficient of x squared, which is a, so that they both can have a situation where x squared has no coefficient. That is, the coefficient of x squared should be 1 on both equations. So dividing this through by x squared a, we'll have x squared plus b a x plus c over a, b over ax rather, equals to 0. So let's call this equation 1 and let's call this equation 2. Now, comparing both of them, since they're equivalent, we'll have now that our minus alpha plus beta is equal to b over a, which also implies that alpha plus beta is equal to b minus b over a. And then comparing equation 1 and 2 again, we have that alpha beta is equals to c over a. Now, this is called the product of the sum and product of the roots. So whenever we are giving roots, we are giving two roots of an equation, without much ado, we can immediately form the equation without much calculation, just by summing them up and then imputing it into this to generate the quadratic equation. Another way to prove that alpha plus beta is equal to minus b over a and alpha beta is equal to c over a is by using the quadratic formula. Now, I may not go all the way with this, but the quadratic formula x is equal to minus b plus or minus root b squared minus 4ac over 2a. Now, this means that we have two x values when we solve using this formula. And let's call the two values either alpha. Let's call the two values alpha and beta. Alpha will be equal to minus b plus root b squared minus 4ac over 2a. And beta is equal to minus b minus root b squared minus 4ac over 2a. Now, in using these two equations, when we substitute our alpha plus beta will surely have minus b over a. I don't have the time to go into all of that. If you sum this up, you'll have minus b over a. And then when you find the product of alpha and beta, that is, you multiply this and this, you will have c over a. I don't want to go into that in this video. I don't want to go into that. But if you attempt it yourself, you add this and this, you have minus b over a. And if you find the product of this and this, you have c over a. This whole thing goes to show that any quadratic equation can be written in the form x squared minus the sum of the roots, which is alpha plus beta x plus the product of the roots, which is alpha beta, equal to 0. So every quadratic equation can be written in this form, where alpha plus beta is equal to minus b over a, and alpha beta equal to c over a. Now let's work on some examples. Example number 1, we are given if the roots of 3x squared minus 4x minus 1 is equal to 0. If the roots are alpha and beta, find alpha plus beta and alpha beta. Now, using what we've already worked on, 3x squared minus 4x minus 1 equals to 0. Now, let's compare that with the standard form of quadratic equation. From this, we can deduce that a equals 3 and b equals minus 4 and c equals to minus 1. And then we've been asked to find alpha plus beta, which is equal to minus beta over a. Now, what are b? Minus 4. What are a? 3. That means the sum of the roots is equal to 4 over 3. And also we're asked to find the product of the roots, alpha beta. Alpha beta is equal to c over a. Now, what's our c? Minus 1. What's our a? 3. So this is the final answer. Let's try another example, number 2. If alpha beta are the roots of 2x squared minus x minus 2 equals 0, find the values of x squared plus beta squared, b, alpha minus beta, and c, 1 over alpha plus 1 over beta. Now, in dealing with this, what you want to do is that you want to express this, you want to express each of the values they've told us to find in terms of alpha plus beta and alpha beta. Now, we've been asked to find alpha square plus beta square, alpha minus beta, and 1 over alpha plus 1 over beta. Now, you want to express all of these in terms of alpha plus beta and alpha beta. Now, the equation is 2x squared minus x minus 2 equals to 0. Now, let's first of all find our alpha plus beta. Alpha plus beta is minus b over a. So from this, comparing this with our ax squared plus bx plus c equal to 0, we deduce that our b is equal to minus 1 and our a is equal to 2. So alpha plus beta here is equal to 1 over 2. So alpha beta, that's an alpha beta, which is equal to c over a. From here, our c is equal to minus 2. And our a is equal to 2. So what we have here is minus 1. So now the question is that we are to find a squared plus beta squared. Let's start with a squared plus beta squared. Now, just like I said, we want to express this in the form of alpha plus beta and alpha times beta. How do we do that? We know that alpha plus beta all squared is equals to alpha squared plus 2 alpha beta plus beta squared. Now, remember what we are looking for is alpha squared plus beta squared. Now, let's make alpha square plus beta square the subject of this formula. We have alpha square plus beta square. This now, 2 alpha beta will cross over, and then you have alpha plus beta all squared minus 2 alpha beta. So we now see that alpha square plus beta square has been expressed in terms of alpha plus beta and alpha beta. That is the sum of alpha and beta and the product of alpha and beta. So now what do? We simply just substitute the values of alpha plus beta and the value of alpha beta. So our alpha square plus beta square is now equal to, what's our value there? We have 1 over 2 squared minus 2. What's our value here? Minus 1. So this is equal to 1 over 4 minus, okay, this becomes plus 2. So this will give us 4, 1 plus, give us 9 over 4. So that's that. And then the second, we have alpha minus beta. Now, we want to express this in terms of alpha plus beta and alpha beta. So we'll do this. All squared is equal to alpha square minus 2 alpha beta plus. So what we do now is alpha minus beta all square is equals to, we bring alpha square plus beta square together. And then recall that alpha squared plus beta squared is equals to, from this, we know that it's equals to alpha plus beta all squared minus 2 alpha beta. So substitute this into this. We have alpha minus beta all squared is equal to alpha plus beta all squared minus 2 alpha beta minus 2 alpha beta. So what we'll have is alpha minus beta all squared equals to alpha plus beta all squared minus 4 alpha beta. So our alpha minus beta is equal to the root of all of this, all squared minus 4 alpha beta. So you see now that this is now expressed in the terms of x plus beta and alpha beta. Now let's substitute our values for the sum of the roots and the product of the roots, which is what we'll have now is alpha plus beta is half squared minus 4 minus 1. So what we have now is we'll have 1 over 4 plus, this becomes 4. So what we have now is roots 4, 1 plus. This becomes root 17 over 2. That's our answer. Alpha minus beta is equal to root 17 over 2. Now finally, let's do for 1 over alpha plus 1 over beta. Remember, we want to express this in terms of the sum of the roots and the product. Now, in adding this, we'll have alpha beta, and this goes here, we have beta, this goes here, we have alpha, and you agree with me that this is also equal to this. So we simply just impute our values, we substitute our values for the sum of the roots and the product of the roots. So here we have 1 over 2 over minus 1. So final answer is minus 1 over 2. It's that simple. Now let's move on to the next example. This third example, we are given if alpha, beta are roots of the equation x squared plus 5x minus 1 equal to 0, find an equation whose root is 1 over alpha and 1 over beta. This is how you solve something like this. You're giving your equation, this is example 3. You're giving your equation x squared plus 5x minus 1 equal to 0. From here, we can simply deduce that our sum of the roots alpha plus beta equals to, remember, alpha plus beta is equals to minus b over a. Now, what's our minus b? What's our b? Our b is 5. What's our a? Our a is 1. So the sum of the roots here is minus 5. Then the product of the root is c over a. What's our c in this case? Minus 1. And what's our a? 1. So product is minus 1. And the question is, we should find an equation whose roots are 1 over alpha and 1 over beta. Now, for an equation whose roots are 1 over alpha and 1 over beta, this is what the equation would look like. The equation will be x squared minus the sum of 1 over alpha and 1 over, no need to write that, 1 over alpha plus 1 over beta x plus 1 over alpha beta equal to 0. So what we want to do now is we want to find 1 over alpha plus 1 over beta. 1 over alpha plus 1 over beta is equal to alpha plus beta over alpha beta. Remember from our last example. So we've already found our sum of the roots here. We have minus 5, and then our alpha beta is minus 1. So this means it's equals to 5. Then our product, 1 over alpha beta is equal to, simple, our product is minus 1. So we have 1 over alpha times beta is minus 1. So we have minus 1. So this means this is minus 1. So the equation whose roots are 1 over alpha and 1 over beta is x squared minus, what's our sum? 5. 5x plus, what's our product? Minus 1. Minus 1 equals to 0. So this is x squared minus 5x minus 1 equals to 0. So that's how you solve that. And let's do one more example under this. One more example similar to this. So we are given, if alpha and beta are roots of 3x squared plus 5x minus 1 equal to 0, form the equation whose roots are alpha squared and beta squared. This is the equation we are given. 3x squared plus 5x minus 1 equals to 0. Let's just do this to make it easier, easy for us to compare. So from this, we know that the sum of the roots, that is alpha plus beta, being which is minus b over a, is equal to, now comparing this, our b is equal to 5. Our a is equal to 3. So the sum of the roots is 5 over 3. Then the product equal to 6 over a. Comparing this, our c is equal to minus 1 and our a is equal to 3. So we have minus 1 over 3. So now they say we have to form the equation whose roots are alpha square and beta square. Remember, in dealing with this, we want to express, now for an equation whose roots are alpha square and beta square, the equation formed will be x squared minus alpha square plus beta square x plus alpha square beta square equal to 0. But remember that we want to express this alpha square plus beta square in terms of the sum of alpha and beta. We want to express whatever we have here. We want to express this in the terms of alpha plus beta and alpha beta. I've already established from the earlier examples we did that this is equal to alpha plus beta all squared minus 2 alpha beta. So what are alpha plus beta? We have minus 5 over 3 all squared minus 2. What's our alpha beta? We have minus 1 over 3. So what we'll have now is this becomes 25 over 9 plus 2 over 3. Sum this up and you should have 925 plus 6, which is equal to 31 over 9. That is for alpha square plus beta square. And then alpha square beta square is the same thing as alpha beta all squared. So what's alpha beta? Minus 1 over 3 all squared. You have minus, no, you don't have minus anymore. You have 1 over 9. So in substituting these values now here, this value here, we have the equation formed is x squared minus, what's our alpha squared plus beta squared? 31 over 9 x plus, what's our alpha square plus beta square? It is 1 over 9 equals 0. So this is our answer, but we can do something to clear out the fractions. We multiply through by 9. So multiplying through by 9, we have 9x squared minus 31x plus 1 equals 0. So that's our final answer. Now, here are some exercises for you to practice with, and that's that for this video. If this video was helpful, please like and share it. Also, let me know in the comments if you face any difficulties with the exercises. Thank you very much. See you in the next video.